We're given this equation for an ellipse and we're trying to find the eccentricity of it. So the eccentricity equation is given by the c divided by the a. This is the quotient of the distance from the center to the focus and the distance from the center to the major vertex, okay, the a value. So in this case, we know absolutely that a is greater than b. And why do we need it? Because in the standard form equation, we know that the bottom will be either a squared or b squared, and we have to determine which one it is. Since a is greater than b, we know that 9 is a squared, because 9 is greater than 5, right? So a must be equal to 3, and that means b is equal to the square root of 5, right? Because b squared is 5, since we already found the a value. So b is the square root of 5. Okay? And now using the equation a squared is equal to b squared plus c squared, we can find the c value because we know the a and b. So c is equal to the square root of the a squared minus b squared. Right? Because to solve for c squared, you have to subtract b squared. So c is equal to the square root of 9. That's the a squared, and b squared is 5, right? So minus 5. So that is square root of 4, which is 2. So know the c value is 2, so that means the eccentricity is going to be 2 over 3. C divided by a. Now I want you to notice what eccentricity really does. Instead of just remembering what you should do algebraically, you should really understand graphically what the eccentricity does, just in case if you forget the formula. So as you can see, the c value, which is represented by the numerator in this fraction determining the eccentricity, the c value is the distance from the center to each focus in a given ellipse. And the a value, the bottom here in this fraction, is the distance from the center to the major vertex. Why do I say major vertex? Because we're talking about a major axis being parallel to the y-axis here. If you want to talk about the major axis being parallel to the x-axis, you can refer to these two examples here. So as you can see, the principle is the same. It doesn't matter what the orientation or the major axis is, as long as you understand the principle behind the c and the a and how they determine the eccentricity. The eccentricity equation and the principle will not change even if you change or rotate any of these ellipses to change the look of it, right, and the orientation, the position, etc. Right? The principle is the same. So c divided by a. So as you can see, the eccentricity, it's very important to realize that the eccentricity lies between 0 and 1. And I'm going to make this e red so that you can see where it lies, right? It's between 0 and 1, and that you should really understand and memorize, actually. So when you memorize, you should understand what happens when the e value is actually 0. When the e value is actually 0, you get an ellipse that looks like a circle, right? So basically, when the e value is 0, it is a circle. The reason it's not included in the eccentricity is that you want it to be an ellipse, right? If the e value is 0, it's going to be a circle. But we're talking about ellipses. That's why e never really gets to be 0, right? It gets closer and closer to 0 as the distance from the center to the focus decreases, right? And it makes sense because when you decrease the c value and you're making it closer and closer to 0 in value, you will also make this whole fraction get closer and closer to 0 because you're basically decreasing the numerator. Okay? So as you can see in these two, the focus is closer and closer to the center in these two orientations here. Whereas here, whereas here, you're actually stretching the ellipse, in this case vertically, when you are increasing the distance from the center to the focus, when you're increasing the c value. And in this case, you can see this picture. It's stretched horizontally, and here it's stretched vertically whenever the c value is increasing, right? So as you can see, the c value takes more than half of the a value, and here as well. That's why the fraction gets closer and closer to 1, and that's why the eccentricity gets closer and closer to 1. The reason why eccentricity is never really 1, because you won't be able to, you won't be able to visualize the eccentricity. The width of it here in this case will be impossible to view. Even under a microscope, you would not be able to see the width, because it would be stretched out infinitely, right? And that's when the eccentricity would be 1. The stretch is infinite. That's why the eccentricity is never 1. And like I said, the eccentricity is never 0, because then you would have a circle. So eccentricity will be between 0 and 1. In this case, we solved the eccentricity and we found that it was 2/3. Okay? 2/3 would pretty much look something like this. And why not this? It would be, the major axis would be parallel to the x-axis, because we're talking about the a value being 3. In this case, whenever the a value is 3, since it's under the x's here, we know that the x-axis, or parallel to the x-axis, well, in this case, it's going to be right on the x-axis, because the center is 0, 0. There's nothing subtracting or adding to the x's here and the y's. So the center would be 0, 0, the origin, right? So the center would be the origin. So it would be right, the major axis would be right on the x-axis in this case. But in this case, if you want to experiment and confirm your x coordinates for the major vertices here, you just set y is equal to 0, right? Because you know that the x-axis has y equals to 0 as its coordinate, right? So when you set y is equal to 0, x squared over 9 is equal to 1. So x is going to be solved for, which will be plus minus 3, right? So plus minus 3 means you're adding the 8 to this to get to here, and then you're subtracting 3 from here to get to this point, to this major vertex, right? So I explained how to do this in the previous videos, but I'm just explaining to you that the standard position is actually this position, with this being the origin for the given equation. Okay, just in case if you wondered how that it's not just eccentricity at play here, but it's also what this really looks like, right? This equation looks pretty much like this, except that the center is also the origin. Okay, and this major axis is right on the x-axis. Thanks for watching, and I'll see you in the next video.